Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we modulate your brain with weird and wonderful science. I'm Ian Woolf. On this news-only edition, you'll hear about decontaminating masks, COVID kids, eye spots on cows, the Neuralink demo, and ultrasonic choice. Mask decontamination? To combat the confusing and contradictory advice on how to decontaminate and reuse N95 face masks, a team of 60 scientists and engineers, students and clinicians drawn from universities in the private sector, coordinated by Stanford University bioengineer Manu Prakash, have created the N95decon.org website to collect together the latest peer-reviewed research results. Their goal is to provide overwhelmed health officials with reliable, easy-to-follow scientific information about the pros and cons of 3 decontamination methods should local shortages force a choice between decontamination and reuse or going without face masks. But N95decon.org also has information on decontamination for the rest of us too. N95 masks use a delicate electrostatic repulsion filter to deflect 95% of particles and droplets, and common disposable and cloth face masks just use a plain filter. The site has fact sheets, technical reports and links to papers about the effectiveness of cloth masks and respirators, and examines in detail 3 methods of decontamination, and warns you how not to decontaminate masks. They go through the evidence and methods of using hydrogen peroxide, ultraviolet C at wavelengths near 260 nanometers, humid heat, and weight and reuse, as advocated by Ian Bryce in a previous Diffusion interview. Here's what doesn't work. For N95, avoid soapy water, alcohol, bleach, and waiting overnight. Soaking in soapy water has been shown to degrade the filtering abilities of several N95 mask models, but it should work for cloth masks. Application of isopropanol or ethanol, such as hand sanitizer, has been shown to stop N95 filters working as well as they used to, in at least one model of N95 mask. Soaking in liquid bleach has been shown to degrade the N95 filters. However, wiping 3 times with a fresh bleach-containing wipe that contains 0.9% hypochlorite has been shown not to cause damage to multiple N95 mask models and can decontaminate for at least one model pathogen that stood in for the coronavirus in the experiments. Bleach residue can harm your health, especially if you suffer from asthma or are sensitive for other reasons. Bleach can burn you or stop you from being able to breathe. Giving the bleached masks 18 hours to evaporate all of the bleach by off-gassing in a fume hood has been shown to reduce bleach residue. If you don't have a fume hood, then don't risk using bleach on your mask. The SARS-CoV-2 virus has been shown to remain active on surfaces for 3 or more days, indicating that overnight storage at room temperature does not sufficiently decontaminate N95 masks for use the following day. What does work is keeping masks in storage for at least 7 days at 22 degrees Celsius or 72 degrees Fahrenheit, while being aware that if the temperature is lower than that, then the virus may stay alive for much longer. Dry heat works only if it's 70 degrees Celsius or 158 degrees Fahrenheit for 60 minutes in lab conditions. high humidity with the heat helps kill the virus. Some models of masks will be damaged by the heat, while others can be reheated multiple times before they're damaged. It depends on the model of the mask and how precisely you can monitor the heat. My conclusion is that it's not safe to try this method at home, but if you must put your mask in the oven, then at least put a big pan of water in with it to raise the humidity in the oven. So if you work in a hospital or lab and you can't get new masks, you may be able to decontaminate and reuse your N95 masks for a while. For the rest of us, we could leave the cloth or use disposable masks alone for over a week if it's at least 22 degrees Celsius inside the room. Or get cloth masks with pockets and replace the filter. And wash the mask in soapy water after each use. Go to n95decon.org for all the details and stay safe. COVID-19 kids. Governments eager to get parents back to work in the pandemic have pushed the idea that it's safe for children and teachers to congregate in schools without distancing or masks because, they claim, children are magically immune to COVID-19. They base this claim on the reports that very few children get severe COVID-19 symptoms, and ignore the even larger reports of schools forced to close because children and teachers test positive to COVID-19. A new study shows that children can carry the SARS-CoV-2 virus in their nose and throats for several weeks without showing any symptoms of infection and spread the illness. The study examined 91 asymptomatic, pre-symptomatic and symptomatic children diagnosed with COVID-19 between February 18th and March 31st at 22 centres throughout South Korea. Amongst those patients, 22% didn't show any obvious symptoms and remained without symptoms throughout the study. Another 20% were pre-symptomatic, meaning that they didn't look or feel sick at the time, but eventually got symptoms later. In total, more than half of the children, 78%, did show symptoms, which included fever, cough, diarrhea, abdominal pain, and loss of smell or taste, amongst other symptoms. The duration of the symptoms appeared to vary, ranging from 1 to 36 days. That's a long time. The data showed that only 8.5% of these patients with symptoms were diagnosed with COVID-19 at the time their symptoms began. 66% of the patients with symptoms had symptoms that were not recognised before they were diagnosed, and 25% developed symptoms after they were diagnosed. Infected children may be more likely to go unnoticed, either with or without symptoms, and continue on with their usual activities for over a month, which may contribute to viral circulation within their community. The study found genetic material from the virus was detectable in the children for a mean of 17.5 days overall. Even in the children who had no symptoms, the virus was detectable for 14 days on average. It's also possible that the virus remained in the children even longer, the study said, because the date of initial infection wasn't identified. Testing only children who show symptoms will fail to identify children who are silently shedding virus while moving about the community and schools. In places where use of face masks is not widely accepted or used by the general public, children who carry the virus without showing symptoms may act as a way of keeping the virus alive and spreading in the community. Government health officials need to accept that children get infected with the virus that causes COVID-19 and that they can also get sick with the disease, even if very low numbers of them die of the disease. 1 in 5 children who are infected don't show any symptoms but are still infectious for over a month. Our health policies around schools needs to accommodate the facts, even when they interfere with parents going to work. The paper was titled Clinical Characteristics and Viral RNA Detection in Children with Coronavirus Disease 2019 in the Republic of Korea and was published in the Journal of the Medical Association Pediatrics. Don't blink. Paint some eyes instead. In northern Botswana, researchers painted eyes on cows' behinds to prevent them being attacked by lions and leopards, and it worked. Money for finding out how effective the technique was in northern Botswana was crowdfunded on experiment.com, with further funding from Cleveland Metro Park Zoo to lead author and University of New South Wales PhD candidate Cameron Radford, and from Taronga Conservation Society Australia to research associate Neil Jordan, who works with the Botswana Predator Conservation Trust. Ambush predators sit and wait for prey, often from a concealed position, and then launch a rapid surprise attack. Cameron Radford says he got the idea to paint eyes on cows' behinds when he saw a lion abandon a hunt the moment the impala it was hunting looked at it. Insects, fishes, mollusks, amphibians and birds use concentric circles to deter predators, and some of the markings look like real eyes. No current-day mammals have evolved eye spots to deter predators, although in Australia many people wear helmets with eye spots in the back to deter magpies from attacking their heads. Woodcutters and other forest users have worn ornamental human face masks on the back of their heads in the Sundarbans in eastern India and western Bangladesh to deter ambush tiger attacks. This project is the first to scientifically test the idea of adding eye spots to prevent attacks by predators. The team selected 14 cattle posts, each with one cattle herd, that had reported lots of attacks by predators in recent months. Within each herd, adult cattle were assigned into one of three treatment groups: carefully painted eye spots, painted crosses, or no marks at all. During the study, they had 49 painting sessions before the cattle were released from overnight fenced enclosures. Out of 683 cows with eye spots, none were killed. Out of 543 cows painted with crosses, 4 were killed by predators. Out of 835 unmarked cows, 15 were killed by predators. Out of the attacks on the cattle, 18 were by lions and only 1 was by a leopard. The cows were fitted with GPS tracking collars to see whether they wandered out of their enclosures when they were attacked, to make sure the only difference in survival is whether eyes, crosses or nothing were painted on the cows. The team found that cattle painted with eye spots on their behinds were significantly more likely to survive than cattle painted with crosses, and unmarked cattle, despite all the groups of cattle being exposed to the same risk of being taken by predators. Unexpectedly, more of the cattle painted with crosses survived than those with no markings at all. The researchers conclude that applying any kind of artificial marks to high-value livestock is a cost-effective tool to reduce the chances of livestock being killed by predators. Perhaps this is an unexpected side effect of branding? However, while some of the cattle marked with crosses were killed by the big cats, none of the cows marked with eye spots were killed. The eyes have it. Their paper was titled "Artificial Eye Spots on Cattle Reduce Predation by Large Carnivores" and was published by the journal Nature.
Computers are generally used in any of three ways. First, as a control or balance. Second, as a function of design. Third, as a simulation or model of life, where we can see the effect before taking the action. As a control or balance, the calculator keeps our complicated systems functioning. It determines the logistics of raw material, its inventory and flow, history and performance of tools, and of personnel, production rate and quality, public utilities rates and flow, cost accounting, payrolls, billing, and all the ramifications of insurance. And in addition, presents the broadest possible basis for making decisions. As a function of design, the calculator provides creative man a higher platform upon which to stand and from which to work. Data processing removes the drudgery, but imposes new and broad responsibilities. The designer must be able to state precisely what it is he needs to know. This is not always so easy. He must formulate a general plan of procedure. This plan or program takes the greater part of all the time involved. He must write a concise step-by-step list of instructions, translate it into a digestible code, and feed it to the computer. Then he must provide the machine with all pertinent background information and related data. The preparation may have taken months, the actual calculation hours or even minutes. But once set up, it can attack the problem with infinite variations and trustworthy memory. Perhaps the most challenging use of the computer is the simulation of real situations. If, for example, a machine is properly programmed and is provided with sufficient numerical data concerning a chemical plant, then the computer begins to take on the functions of a working mathematical model of that chemical plant, in which it is possible to determine the probable effects of many possible courses of action. Today, there are working mathematical models of railroad systems, rocket engines, complete reactors, and whole living communities. The calculator is helping to define society's most complicated problems. It is a tool for turning inspiration into fruitful prediction. As an information machine, it has done much to broaden the base of our growing concepts. But the real miracle is the promise that there will also be room for those smallest details that have been the basis for man's most rewarding wishes.
You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. CyberPig. Elon Musk last Friday hosted a 2-hour live stream on YouTube to demonstrate the progress on his Neuralink brain-computer interface implant project. A year ago, Elon promised that Neuralink would be implanted into people to treat paralysis in 2020. In the 2020 demonstration, Elon explained that he hopes that in the future his implant will cure all neurological problems, from paralysis to memory loss, as well as allow you to have remote control of machines and be able to directly input data to your brain. Elon teased his fans with the idea that we wouldn't be able to tell if he already had a Neuralink implant because the implant would be hidden by his hair. It's invisible. Neuralink has changed the design from being behind your ear to on the top of your head to shorten the wires. They've added magnetic charging of the kind you find in the latest phones and watches. The battery now lasts for a day, which implies you somehow have to lie or sit still while a magnetized plug sits on the very top of your head for about 2 hours. This device has 1,024 wires. Recording just 30 neurons with 30 wires in the motor cortex of volunteers' brains as they imagine moving their arm is enough to allow them to control a computer cursor on a screen. What could we do with 1,024 neuron recordings? We didn't really find out in this demonstration. After 15 minutes of slides, Mr. Musk finally pulled aside the curtains to show his 3 little pigs. The first little pig had a Neuralink implant. The second little pig used to have a Neuralink implant, but had it removed. And the third little pig had none. Mr. Musk explained that the little pig who had the implant removed was there to demonstrate that the implant surgery is reversible and without harmful effects. The presence of the little pig that never had an implant was maybe the control? The other little pig, we were told, now has a Neuralink implant. But we were never shown the scar or any evidence that this was true. What was true was that the pig was not doing what they wanted, which made Mr. Musk giggle. It finally had demonstrated to him the old adage, never perform live with animals or small children. The pig continued to be disobedient for several minutes while Mr. Musk kept giggling. For some reason, this reminded me of how unions are banned from Tesla factories. When the pig finally came out from the corner of its pen, we were shown a split screen where every time the pig's snout touched something, a spike would show on the screen. We were told that these were signal spikes coming from the implant. Elon next demonstrated that when he switched the implant to electrical input instead of output, that some nearby neurons lit up in a real-time 2-photon microscope brain scan. Unfortunately, he was unable to tell us if the neurons lighting up affected the pig in any way at all. The pig couldn't say. Which is a shame, because if he could help the pig talk, we'd all be very impressed. The last demonstration was that the signal from the implant was fed into software that was able to predict in real time how the pig would choose to move its body. We saw an animation of the software's prediction of movements overlaid on top of video of the pig moving. I guess this could be useful for controlling prosthetics using the implant in the future. But as at this point Elon was just talking about how this is like an implanted Fitbit, it looked more like a creepy surveillance device. The remaining time was all questions and answers about his hopes and dreams for after it works. I hope they build in a security system to protect the input to the brain. Thin, flexible electrodes corrode fairly quickly in the brain and cause tissue damage called gliosis. Neuralink hasn't solved this problem. And until they do, it's not going to be an implant you have for life. You sacrifice some brain tissue when it goes in, and again when it corrodes, and a third time when it's removed. At this point in its development, it's barely even a prototype that you can't do much with, and certainly not yet worth the harm it would cause a human subject. Many people have credited Musk's Neuralink company with the invention of the robot that performs the implant surgery, saying that while the Neuralink device itself still doesn't do much, it's the innovation of the surgical robot implanting the electrodes that's the real invention. The problem is that Neuralink's surgical robot is taken directly from the American government's Defense Advanced Research Project's sewing machine surgical robot for implanting electrodes, developed at the University of California, San Francisco. For now, Neuralink has a government-funded surgical robot, a brain-computer interface with 10 times more electrodes than some of the competition, a radio connection, predictive software, and a disobedient cyber pig. The other message from the demo is that Neuralink is hiring. Major look! Researchers at Stanford University used ultrasound to force monkeys to move their eyes against their will. The macaque monkeys have been trained to direct their gaze left or right at particular objects that appear on a screen in front of them in order to get a reward of sweet juice. However, when the ultrasound pulse was focused on their brain's frontal eye field area, the monkeys could be forced to look the other way and miss out on their reward. The experiments only involved 2 monkeys in 6 trials, so larger studies will be needed to validate the results. The researchers hope that their work could lead to treatment for choice-making disorders like addiction. I'm sure no military, police or government agencies will come up with nastier applications for forcing choices through remote control by ultrasound. The paper was titled Remote Brain Region-Specific Control of Choice Behavior with Ultrasonic Waves, and was published in the journal Science Advances. And that's all from us this week on Diffusion. Are you a scientist, artist, biohacker or maker who'd like to be interviewed about your work? Would your company like to sponsor Diffusion? Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. The news music was Rhinos Theme by Kevin McLeod of Incompetech.com. I produce Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including Radio Blue Mountains 89.1 FM in New South Wales, 8CCC in Alice Springs and Tennant Creek, 2NVR in Nambucca Valley, 3MBR in the Mallee Border districts of Victoria and South Australia, City Park Radio 7LTN in Launceston, Tasmania, and 2XXFM in Canberra. Diffusion is now narrowcast on Indigo FM 88 in northeast Victoria. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 1,000 previous episodes archived at diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Join my patrons at patreon.com/diffusionradio. Make a donation through paypal.me/Ian Woolf. Support Diffusion by buying from the affiliate links at diffusionradio.com/support. You can now see the video of my interviews with James Hayes about odour, Ian Bryce about masks, Bonnie, Kirsten and Martin about the search for life on Mars, and Sylvia Vicenzi about brain development on the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.